Welcome back to Kamal Kunj Home Academy, Encounter with Physics. In this session, we will discuss about motion in a plane with constant acceleration. Now suppose a particle is moving in xy plane freely and its position at any point at a point t is at A, whose coordinates are xy, and after time t plus delta t, its position is at B, whose coordinates are x plus delta x and y plus delta y. Coordinates at time t is xy and coordinates after time t plus delta t is x plus delta x, y plus delta y. This is x y x plus delta x y plus delta y. It will draw parallel to x-axis from A, C. Now, position of particle at time t is A, whose coordinates are xy, and position of particle is at B after time t plus delta t. So, displacement of the particle after time interval t and t plus delta t is displacement of particle after time interval t and t plus delta t is delta r equal to AB vector AB is equal to vector AC plus vector CB. This is equal to AC is delta x unit vector I plus CB is delta y unit vector j along y axis. I is the unit vector along x axis, y is the unit vector along y axis. This implies that delta r upon delta t equal to delta x by delta t unit vector I plus delta y upon delta t unit vector j. Now take the limits as delta t tending to 0. This implies that limit delta t tending to 0, delta r for delta t equal to limit delta t into 0 delta x upon delta t unit vector I plus limit delta t into 0 delta y upon delta t unit vector j. This implies that this is velocity v equal to this is dx by dt unit vector I plus dy by dt unit vector j. So here dx by dt is the velocity along x-axis and dy by dt is the velocity along y-axis. That is Vx is equal to dx by dt and Vy is equal to dy by dt. Component of velocity along x-axis is the component of velocity along y-axis. This implies that V is equal to Vx by plus Vy unit vector j. Now if you again differentiate, acceleration is equal to differential of velocity with time equal to dvxy dt plus dvy dt unit vector unit vector I. dvxy dt is the acceleration along x-axis. dvy dt is acceleration, component of acceleration along y-axis. So this is equal to ax I plus ay j. Ax is the component of acceleration along x-axis. Ay is the component of acceleration along y-axis. Now if AX acceleration along x-axis is constant, now if AX is constant, then the equations of motion along x-axis are Vx is equal to Ux plus Ax into T. X is equal to Ux into T plus half Ax T square and Vx square is equal to Ux square plus twice Ax to x. So if Ax component of acceleration along x-axis is constant, then it becomes linear motion along x-axis with constant acceleration. Similarly, if Ay is constant, component of acceleration along y-axis is constant, then equations of motion along y-axis are Vy velocity after time t Uy plus Ay into t and y is equal to position equation y is equal to Uy into t plus half Uy into t square and velocity after time t Vy square equal to Uy square plus twice Uy into y. So these are the linear equations along y-axis. Thus, you see that plane in motion here is split up into x-axis and y-axis. Split into linear motions along x-axis and y-axis with constant acceleration. Thus, motion in a plane with constant acceleration is split up into linear motions with uniform acceleration along x and y axis. Now, an important example of motion in plane with constant acceleration is projectile motion. An important example of motion in plane with constant acceleration is projectile motion. So, projectile motion is an example of motion in a plane with constant acceleration. Now we will discuss about projectile motion in the next session. Till then, goodbye and thanks for watching.